Hello YouTube, this is a quick video on computer hacking. I'm going to tell you the ways in which we hack computers for educational purposes only, obviously, and I hope you enjoy it. Now, the reason I do this is one of the most searched things on Google and YouTube is how to hack computers, and most people find nothing. And there's a good reason for this, and the reason is that what most people think is computer hacking is totally irrelevant and won't work anymore. And I'm going to show you the reason behind that. And this is the first problem with computer hacking. Now, once I've done this, I will tell you a bit more about how we do hack computers in the more conventional form, or the way in which most people think you do, through code and through maths and numbers. So there's a man called Fermat, or was called Fermat, and he developed a little theorem, and this is what the company RSA uses in their encryption. Now, this is quite a stripped down version of it. Usually, numbers that we use will be 10 to the power of 270 digits. That is how large these numbers are. To give you some idea of how large that number is, the number of protons in the known visible universe is about 10 to the power of 80. That is how many protons there are, and that is the numbers we use in encryption. They're huge. Computers, even if you got every computer in the world, added them together, stuck them all into one machine with one goal of hacking something with this type of encryption, it would be impossible. It couldn't be done. So I'm just going to show you why. So to start with, we need two private keys, P and Q. Now for this, I'm going to set P as 17, they have to be prime, and Q as 11. Now I'm also going to set C, I'm going to set the following equations, which is Fermat's little theorem, is C, the ciphertext, is equal to the message text, which is the raw form. Say, if I was sending hello, the message text would be hello, and I'll tell you how to get that in a minute. M to the power of the encryption key, or E, mod N. Now, a lot of people don't know what this function is. Mod is a very useful function in mathematics. It's totally unreversible. It means divide, and whatever the remainder is, that's the answer. So just a quick example, 42 mod 10 isn't 4, it's 2. It's what it is. And 72 mod 10 is 2. And there is a very good reason for using this, in that it's totally unreversible, and I'll quickly show you why. If we are given that something, I'll use Z, something is equal to, so something, sorry, has been, so some number has been applied to the mod of 10, and we know that it equals 2. I'll use a different number for ease, 3. It equals 3. This could be any number in the known universe with the with 3 on the end. Any number. With any number that you can think of with 3 on the end could be Z. So that is why it's totally unreversible. We have no idea what the number is, and again, searching through those to find the number is impossible for computers to do. It would take too long. So E, we also need to set the encryption key is 7. Now this will be set by a server, and these numbers will change every minute. As I said, these numbers wouldn't be this short. They would be 10 to the power of 270 digits. Now, the second equation we need to know is that the encryption key times by the decryption key is equal to 1 when we apply it to the mod of P minus 1 times Q minus 1. Now, I should also explain what N is. N is equal to P times Q. that's what n is. So again, you can see how these numbers would build up to being almost impossible. So the final equation that we need to know is how to get the message text, and the message text is equal to the ciphertext to the power of the decryption key times by the applied to the mod of n. That's at the end how we're going to get back to the message text. So for the purposes of this, I'm going to say that Alice wants to send Bob a kiss. She's going to she's going to send Bob an X in a message, but she doesn't want it to be found, so it's going to be encrypted. Now, how we get X into a number is this. There's something called the Ascii chart, which computers use for text, and it's a set of binary numbers which have a text value. So X in the Ascii chart is 10110000. Now, for those of you who know binary, we use this will be easy. But for those of you who don't, a quick intro is that we use the powers of 2 to assign these ones and zeros a number. So this one here is equal to 2 to the power of 0, 1, 2, 3, 4, 5, 6. So that 0 is equal to 2 to the power of 6. So 2 to the power of 6 is 64. We assign this 0, 1, 2, 3. And then we add all these together. So 2 to the power of 6, 2 to the power of 3, 2 to the power of 4. We add all those up, and what we get is 88. And 88 is equal to our message text. So we can put that in here. So I'll write this down here. M is 88, not M. Now what we need to do is we know our encryption key, so we need to put that into this, so it's to the power of 7. We know P and we know Q, so if we times those together we get 187. So we'll put that in, so mod 187, and we're ready to go. We're ready to find our ciphertext, and this is the text which no one will be able to understand until they've got these keys. So the ciphertext, I'll save you the trouble of working it out. It's 11. So C is equal to 11. And now what we need to do is find the decryption key so that we can use it in the final equation to get M back again. So if we do that, what we find is we get 7 times 1 is times 1 times D is equal to 1 mod P minus 1, so 17 minus 1, 16, times Q minus 1, 11 minus 1 is 10, so 16 times 10 is 160. So this is how we're going to find out D. Now, most of you have probably already worked this out. D is equal to 23. So even with these tiny numbers, we've already got to a power of 23. That's huge. That's a huge power. A lot of calculators might not even handle that. So this is what we're going to do now. We've got the ciphertext, which is equal to 11. We're going to times it. We're going to put it to the power of 23, and we're going to apply that to the mod of 187, and that is in reference to this equation here. So again, I'll save you the trouble, but most of you have already guessed that that is equal to 88. Now the computer puts that back into binary, which is 10110000, and then it uses the Ascii chart to put it back into a letter, the letter which was sent originally, X. And that is impossible for anyone to. If anyone intercepts that message, all they see is C. They see the ciphertext. They see nothing else, which is useless. It's a useless piece of information which can't be decrypted. It can't be hacked. So that's the problem with with hacking in using mathematics. It can't be done. The numbers are just too large. It would take a combination of all computers in the world several billion years to crack one, and if it takes several billion years to crack one, the fact that it changes every minute makes it impossible. There are ways to do it, or theoretical ways at the moment, and one of them, which a lot of you have probably already guessed, is quantum computing. It's where a piece of data can be both on and off at the same time. Quantum, or in a quantum or quantal state, simply means in all states at once. So that is how you would hack this if you had a quantum computer, which I'm going to go ahead and guess that most of you don't have. Also, if you wanted to hack this, another way is long. There is a chance you could guess. It's incredibly unlikely, but you could guess. You could guess it right first time. There's nothing stopping you going in, tapping something in, and hoping that it might work. But that's not the way in which most people hack nowadays. The way most people hack is through something called social engineering. Now, there are lots of guides of this online. If you type in social engineering, it's simply finding ways to trick people into giving you the information you need to hack, giving you their private keys so you can do it this way, or giving you their password. If I want to hack my friend's email account, I could actually go up to him and say, "What's your password?" Chances are he won't give it to me. If I was a lot more sneaky, I could convince him to give me a password. So if you want to start to learn how to hack properly, you want to start with social engineering, and that is essentially acting a part or taking on the role of someone else in order to gain information in which they aren't really supposed to give out. So this way, in the UK, trespassing isn't illegal. So social engineering is technically legal. So if you go into a server room and you manage to convince people to open the door, you manage to convince people that your thing, as long as you don't show them any fake ID, if you convince people simply through words that you are who you say you are, even if you're not, obviously, then that isn't illegal. Even if you download all the information off that server in order to gain that information, then that is fine. So that is one way to do it, and that is probably the main way. The other way to do it is this. It's SQL injections, or SQL injections. Now, SQL is a programming language that databases use in order to sort data in the most efficient and economical way. So, when you type in your account name and when you type in your password, what the website is actually doing, for example Facebook, is it's converting that into SQL, and then it is searching its databases in order for you to log in. Now, if you can work out what that SQL code is without you putting in the actual email address and password, so if you can work out the SQL code, then you do the database searching for the server. You do it bypassing all security methods. So if you're going to learn how to hack, you want to be able to do SQL injections, and SQL or SQL is actually quite an easy programming language to pick up and learn, to become very proficient at it, enough so that you could hack things like Facebook. You would have to be nothing short of a genius, but it isn't impossible. Now, the other way is something called P or NP. Now, the Millennium Problems, one of them is something called P versus NP, and please, by all means, have a go at it. And what it actually means is polynomial time versus non-polynomial time. Now, if I give you a set of numbers, 1, 2, 3, 11, and 19, and I said, find two of those numbers which add up to 20, without thinking, you would go 1 and 19. Well, what a computer would have to do is it would have to go 1 plus 2, no, 1 plus 3, no, 1 plus 11, no, 1 plus 19, yes. And if you hadn't told it to stop there, you told it to check all possibilities, it would carry on going. So 1 plus 2, 1 plus 3, 1 plus 11, 1 plus 19, 2 plus 1, 2 plus 3, and so on. Now, often we set parameters in to speed this up, so as soon as you find the first set of data which works, so 1 plus 19, stop, which is fine. Now, as you can imagine, again, this is a simplified down version. If you had some incredibly large set of data, the example is on the Millennium Problems website, which is in the description below, is that it would take computers forever. That's the problem with it. So what you really want to be doing is find a way to get computers to do it like humans, use intuition or common sense. Now, you win £1 million if you do this, but you don't just win £1 million if you do this, you win £1 million if you don't do this. If you actually can prove that finding that a computer could never do what a human could do, in the standard sense of a computer, if you can prove mathematically that this is impossible, you will win £1 million. So you could either prove that it is possible, and you don't have to prove how to do it, you just have to prove it's possible. Obviously, proving how to do it's a bonus, and you will be a millionaire and get a lot more money after that if you hold the rights to this information. And then there's also, you can prove it doesn't work, which is what a lot of people seem to think it is, but can't prove it. So yeah, P versus MP is the other way of doing it. Now, other ways, which are getting a lot more complicated, is find a leak in the website, so some form of bug that you can't, leaves a vulnerability in the system. That's another way of doing it. Another way, and something which I think you should look up, is Stuxnet. Now, Stuxnet is a computer virus, and it was actually designed to shut down coolant in the reactors in Iran, in Natanz. Now, the ingenious bit about Stuxnet, it was actually a fairly complicated piece of computer code, but it isn't beyond the reach of the average desktop coder. It could be done. The thing about Stuxnet is it had a certificate. It had a certificate which proved that actually it was real. It was a legitimate piece of software, and that allowed it to get in and bypass all virus protection and everything that entails. So the other way to hack, and it's probably the second best way to hack after social engineering, with SQL third, is that if you create computer code capable of getting into a system without being detected, and then either through the net or through some other form of communication, send you files or information, which is a very, very simple piece of computer code if you can work out how to do that. It's incredibly simple to build a computer program which copies information and sends it to a network location. It's incredibly simple. The problem is getting the user to install that, run it in the background, and keep it away from virus detection without the user knowing. And that's the problem. But if you can do that, and a lot of people can, you create a very successful computer virus. Doubtful it's as successful as Stuxnet, but for the home user, if you can build a virus that can do that, you will have no problem getting into most computers. Your difficulties will lie with things like Linux, but Windows and Macintosh PCs, I've noticed, are exceptionally susceptible to this type of attack. This is how you want to be going about it. So for this, I recommend learning C++, C#, Java. Java's a nice way of doing it if you want to run it from a browser, creating an add-on. packaging a program within inside another program. So if I write down these programming languages that you might want to think about learning, HTML is great for website-based hacking, so if you want to hack them through a website. Java is great for hacking on a wide variety of devices. C Sharp is excellent at hacking on nearly every device. C++. And then there's the other one, which I'm not too keen on. It's very, very good for servers and databases, and that's Python. So now most things today have blocks against these, but they are by no means watertight. So if you're going to learn to hack, these are what you're going to need to learn. You're going to need to learn HTML, Java, C++, Python, and most importantly, SQL. SQL is the way to hack databases, and that is what most people want to hack. Databases contain useful information, and it's how we get into accounts. You know, if you're feeling ambitious, feel free to build the quantum computer or work out P versus MP. Scientists have been trying for several years, or even technically hundreds of years, to build a device capable of this, but you could be the person to do it. So good luck. And yeah, there'll be more videos on hacking. I hope you enjoyed. There'll be more in depth. Please like, comment, or anything. Subscribe if you want. There'll be more maths videos, including tutorials for A-level maths and GCSE preparation. If you'd like any content up here, I can work out how to do things, such as quantum encryption, if you'd like. Anything mathematically you'd like me to look up and show you, I will endeavour to do so. Just comment, drop me a message, or like.